Alright guys, we are back for part 2, right?
Yep,
Of
part two of
thermodynamics. We start with enthalpy and...
entropy.
Okay, who wants to talk about enthalpy?
Enthalpy is how much work is in a system,
How much energy?
how much energy is in a system,
Okay,
including how much is given to it.
including the
Yeah.
heat that we give to it. That's perfect. So is it possible to measure enthalpy of a system?
No, but it is possible to measure the change.
That's absolutely right. And it is denoted by what letter?
The uppercase H.
H, correct. Okay, and what about entropy?
The energy that cannot be put to work.
The energy that's in a system that is not available, right?
Yeah,
That's
it can't
perfect.
be put to work.
Okay, it cannot be. Okay, so what is there any other way you can explain entropy? What does
The
it?
disorder in the system.
Yeah, it's a disorder in the system, and it's that thermal energy that's not available for doing work. That's absolutely perfect. Okay, next let's go to.
The laws of thermodynamics.
Okay, that's interesting. How many laws are there, guys?
There are four, and the last,
The last one is called the zeroth law.
Zeroth law, yeah. So what are these laws? What do they describe?
they describe the transfer of energy in any closed system and in our universe.
So in short, it tells us the behavior of energy itself. So wherever energy is in action, these laws apply. Anywhere. Right? That's awesome. Okay, let's go with the first law. Who wants to talk about first law?
Okay, so the first law is that if you give it energy, or if it it releases energy,
Heat. So,
releases heat,
or
then-
you give a heat
or
to a
give heat to
closed
closed
system.
system, then the energy will change.
The energy of the system itself
Yeah.
changes, right? The enthalpy changes. If it gives out heat or we give heat to it, the energy of the system changes. That's first law. Very good. What is the second law?
Enthalpy,
Not enthalpy.
entropy
Yeah.
always increases
Absolutely.
Until it reaches
until
a,
it reaches a point where it can't increase.
a
because
thermodynamic
it's
equilibrium.
Okay, Arjun, take it. What is second law?
So it says that entropy will always increase until it reaches a thermodynamic equilibrium where it cannot increase anymore unless you give it more energy.
Yeah. So like that's engine, heat
Yeah.
engine, we give energy to compress the gas to liquid,
Yeah.
correct? And decreasing the entropy. So we are giving energy there.
Yeah.
If we don't, any system is always going to have increase in its entropy. That is the disorder.
Yeah.
So the disorder is always going to increase in a system. That's an interesting law. Okay, what about the third law?
So the third law is that
It's about the entropy.
the entropy only reaches a constant point when it reaches about absolute zero.
It reaches absolute zero. That's correct. And how about the fourth law, also called as?
Zeroth law.
Okay, what is the zeroth law?
The zeroth law is that if two objects are in
Objects to systems.
two systems are in thermal equilibrium with another system, then they are also in thermal equilibrium.
Those two are also, yeah, that's right. And someone restated these interestingly, Ginsburg. His theorem states the first three.
You can't win,
You can't win. You can't
break even.
break even, and you can't even get out of the game.
Yeah, those are the three laws according to Ginsburg. That's very, very interesting. Alright, now guys, let's talk about
Maxwell's given.
That is very, very interesting. What is Maxwell's demon?
So Maxwell came up with this thought experiment
Okay,
to see if you can decrease the entropy without putting in any work.
wow, that could lead to perpetual motion machines, right? It would decrease entropy by itself. and then increase the entropy and make use of the work. Okay, what was the thought experiment?
So he thought that if there was a demon and there was a door in this box.
Okay, so a box has two chambers,
Yeah.
and the chambers were divided by
By a
a
door.
and that is guarded by.
A demon.
Okay,
And so it has gas.
okay.
Some that is high energy gas and some that is low energy gas.
No, so all the molecules have different kinetic energies, correct? So it's not two gases, it's just one gas, but they all have different kinetic energies. Okay, what does this demon do then?
And so he lets the lower energy,
Slow moving molecules.
slow moving molecules go into one side, and he lets the
High energy.
high energy go into the other side.
So he's going to open the door
Yeah.
for slow moving molecules only on one side.
Yeah.
And for high energy molecules to only the other sides. That way he separates the high and low energy molecules. And what does that lead to?
It leads to the entropy being decreased
On which side?
on the colder side.
Correct. So you end up with one hotter side and lower side, cooler side, correct? And the cooler side has lower entropy. So did we magically, just by letting molecules go here and there, did we decrease entropy without using any work?
No, because the demon already did the work.
Yeah, just that opening the door and directing them itself, that is where the work was applied, correct? So it is not possible to decrease entropy without putting in actual work, right? That's right. And all right, guys, the last concept about heat death and arrow of time. Arjun, you want to tell us what is the arrow of time?
Okay, so all of the other laws of physics will work even if time is reversed.
Okay.
But the
Laws of
laws of
thermodynamics.
thermodynamics state a certain direction of time.
It gives the direction of
Yeah.
time. Okay, tell us how is that?
So the second law tells that entropy always increases.
Correct.
So, like if a cup was dropped, then it would crash.
It would crash.
It wouldn't come and
Like,
rejoin
it
back
would
up.
rejoin
So
into
the
a cup.
disorder always increases, correct? So that is giving us a direction
Of time.
of how the time moves
Yeah.
for the universe, right? So that means it is moving only forward, right? So we can't go reverse the Big Bang,
Yeah.
correct? Because once the Big Bang happens, the entropy is increasing, the disorder is increasing, correct? And also it tells us about heat death. What is heat death? That sounds terrible.
Yeah, it's the heat death of our universe. So it says that because entropy always increases, now there's generations of stars. They're forming and dying,
yeah.
forming and dying. And then, so the universe is going to slightly get hotter.
Yeah, so
Hotter.
gravity is going to
Yeah.
hold it at bay for only certain time.
Yeah.
But as it gets warmer and warmer, it reaches
The
thermal
Equilibrium.
equilibrium. Yeah. So at that point,
can't
that
get
means
any hotter.
no. That means what? The entropy cannot decrease.
Yeah.
Can't
Correct.
decrease any
New
hotter.
stars cannot be formed. So the
And
entropy
matter itself will disintegrate.
disintegrate, right, and cause what is called as heat death.
Death of the universe.
That's terrible. Well, it won't happen for us. Okay. All right. Actually, very good guys, both of you. Very good job. Okay. Really phenomenal job on thermodynamics. All right.
Okay.
So what are we going to move on to next, Arjun?
Electromagnetic spectrum.
Electromagnetic radiation. Correct. That should be a little bit easier. We've done that before. Okay. All right. Good job.